Okay, so this is our lecture on section 2.4, which is surveys and cardinal numbers. The first thing that I want to start this set off with is just a cardinal number formula, and I'm gonna write it down, and then we're not really gonna look at it very much. It's somewhat intuitive, common sense, but let's write this down here. So the cardinal number formula says this. It says the number of elements in the union of A and B. So remember, the n out here means cardinal number, and we're looking at the union of A and B, is going to be equal to the number of elements in A plus the number of elements in B. But then you have to subtract off the intersection of those two sets. Okay? So just to give you an idea of why that is so, think about if you have a set A here and a set B here. And if I were to take a look at the union would be everything in A and everything in B and everything in their intersection. But the intersection is included for both of them, right? They share this space right here. So just to give you as an example here, let's just say that I had 5 elements here, 2 elements here, and 1 element there. You can see, just by counting it up, that if I were to take the union of these two sets, I would have 5 plus 2 plus 1 elements. Okay, so that would give me 8 elements total, right? So what this formula is saying is that if you're going to look at the union, you have to take a look at the number of elements in A, the number of elements in B, but then you have to subtract the intersection because they'll be sharing that value. So this right here, I just calculated by looking at it visually. If I was to use the formula here, the number of elements in A would be 7, wouldn't it? Because I have 5 elements here, I have 2 elements here, and if I add those two together, I would get 7. The number of elements in B would actually be 3, because I have 2 elements here, 1 element there, and that would be 3. So if I wanted to take a look at the union, A union B, it would be this 7 plus this 3, number of elements in A plus number of elements in B, but then I have to subtract off the intersection because this 7 and this 3 both include the 2. Well, that means we've counted the 2 twice, so we actually have to subtract off the intersection, which is 2. And we would end up with here, this is 10 minus 2, which would be 8. So it's the same value that we got by just looking at it visually. Okay, now this formula, the reason I present it at the beginning of this section is we're going to be using it. We'll use it sometimes. You can use it to find intersections. You can manipulate this formula to solve it for the intersection. And you can use it to find one of these other elements. And there's a few problems on your homework where you take a look at this formula. Okay. All right, the bulk of what we're going to do today, though, is really taking a look at working with Venn diagrams and how do we use Venn diagrams to answer questions about surveys and things like that that might be a little bit complicated to understand if we weren't working with a Venn diagram. Okay, so I think I'll do, let's just start with a few problems to get us kind of warmed up here. So this example right here, let's use the numbers that are representing cardinalities to find, and then we're going to find A, B, C, and so on. Okay, so this picture is going to be given to us here. We have a universal set that has 5 elements and 6 elements on the inside of, this is my A, 1 element in the intersection, B, and then 2 elements in that region. Okay? All right, and in part A here, they ask us to determine what A intersect B is going to be. So if we look at the picture that's given to us, the intersection of A and B is occurring in this region right here. And so that would be 1. Okay, and this, by the way, is the cardinality, and they've listed that in the directions, so I'm not using the n here. All right, part B, let's say that we want to find the union of A and B. So the union of A and B, remember union is taking all the sets and pulling them together, so it would be this 6 plus 1, which would be 7, plus 2 more, which would be 9. Okay. In part C here, we're asked A intersect B naught. Okay, well, the first thing is you have to get a picture in your mind of what region that's referring to. So if you can't do it in your head, which, you know, I'm not spectacular at doing these things in my head, so we should draw ourselves a little picture here. Okay, so here's A, here's B. So first of all, B naught is going to be everything on the outside of B. So it'd be all of this. Okay, so that right there is representing B naught. And then if I wanted to also represent A in this same picture, so A and B naught is going in this direction. The A is represented, I'm going to cross hatch mark it like this. Okay. Okay, so if I were to take a look at the intersection of those, it would be wherever I have crosshatch. And that's going to be this region right here, all of this. Okay, so all of that region is representing A intersect B naught. Okay, so if we go back up and actually answer their question, this region right here on my graph is showing that I have 6 elements in it. So this would be, you know, cardinality of 6. Okay. And then part D here, we're still working with this right here. Part D, let's say we want to find A naught intersect B naught. Okay, well again, you've got to have an idea of where that is. And so let's draw ourselves a picture here. If this is A and this is B, A naught is everything on the outside of A. Okay, and B naught is everything on the outside of B. So it would be all of this. Okay, so for the solution to A naught intersect B naught in terms of shaded region, it would be where I have crosshatch again. So you can see that that's all on the outside here, right? All of this is representing where I have A naught intersect B naught. This in here doesn't have crosshatch, this doesn't have anything, and this doesn't have crosshatch. So the actual picture here, for A naught intersecting B naught would look like this. Here's A, here's B, and it would be all the stuff on the outside of A and B. All of this region. Okay, so if we actually go back and to answer their question, what's on the outside of A and B here would just be the 5 elements. So A naught intersect B naught here would be equivalent to 5. Okay? All right, so that's going in one direction where we're given the Venn diagram with the elements and then we try to answer questions based on that. A lot of times we're going to want to go in the other direction where, for instance, we're given this information and we want to make a Venn diagram out of it. Okay, so let's do an example of something like that. So let's try this one. Directions are we want to show a complete Venn diagram, and we're given this information right here. The number of elements in our universal set is 43. The number of elements in A is 25. The number of elements in A intersect B is 5. And the number of elements in B naught is 30. Okay, so they're giving us, again, we're kind of going in the opposite direction of what we did in the previous problem. They're giving us this information, and then we're going to take this and put it on a Venn diagram. So the first thing is I'm only working in this problem with two sets. I see A and B, and that's it. So I'm going to give myself a picture of A and B. And when you're doing these problems, you're always going to start with wherever the intersection is, because that's going to be the place that has the least amount going on in terms of numbers, and it'll be the easiest for you to identify. So I'm going to actually start, and I'm going to label how I do these in what order. So I'm going to work with this piece of information first. Number of elements in A intersect B, and they're telling me that the number of elements there is 5. So that would actually be this region right here. This is where A and B intersect. Okay, so this has 5 elements. All right. Now, once I've done that, I can go and look at this one next, number of elements in A. Because what this is telling me is that the number of elements in the entire set of A is 25. Okay, well, the entire set of A involves this region right here and this region right here. Okay, so I can see that I already have 5 elements in this portion of A. And if I'm supposed to have 25 elements total, then that tells me that this region right here has to have 20 elements in it. So if I took this plus this, then I would get that 25. Okay? All right. The next thing that I'm going to use is I'm going to use number of elements not in B. So they're telling us that that's 30. So we need to take a look at what is not B. Okay, so if I just draw myself a little picture here, here's A and here's B. If this is B in here, then not B is everything on the outside of that. Okay. All right, so what that's telling me is that this region in here that involves A and this region out here is going to have a total of 30 elements in it. Well, I already know that this region on the inside of A has 20 elements from what I've done previously. So that means that what's on the outside here actually has to have 10 elements in it, because total between this region on the inside of A and this on the outside is going to have 30. Okay, notice that we're not taking into account this region or this region, because those are both in B, and this is not B. It's got 30 elements. Okay, so that's how we're going to find that. And then the last thing here is to utilize the number of elements in the universal set. So what this allows us to do is find the number of elements in here. And the reason for that is because I already know the number of elements here, here, and here. There's only one region that I don't know of yet, and that's this region right here. Okay, so the number of elements in this set, or in this subset right here, is going to be our total, which is 43, and then I'm going to subtract off my 20, my 10, and my 5. So